Online classes. In the last class we discussed the Atwood machine. There we derive the general expression for the acceleration as well as the tension and the thrust is acting on the pulley. So in that application what we assume, whatever the pulley system we consider, so this pulley system will be in the state of the rest. The pulley system, the pulley and the rigid support, this entire system will be in the state of the rest. At that time you derive the expression for the acceleration is equal to m1 minus m2 into g by m1 plus m2, and the tension developed within the string is equal to, you derive 2 into m1 m2 into g by m1 plus m2, and the thrust acting on the pulley will be given by 4 m1 m2 into g by m1 plus m2. So when these equations are applicable means, so whenever this pulley will be connected to the rigid support, that means the pulley system will be in the state of the rest. Only these two masses will be in the motion. Only the masses m1 comma m2 will be in the motion. In that case only we have to derive a value, t value and f thrust value. Now what they are asking in this next application is, if the pulley mass system will be moving in the upward direction, with a constant acceleration. The pulley will be moving in the vertically upward direction with a constant acceleration. At that time they are asking that what is the acceleration value, what is the tension value, and what is the F thrust, that is upward thrust that is acting on the pulley block system. Once again, in the previous case, here the pulley will be connected to the rigid support. At that time you derive the expression for the acceleration, tension and F thrust. In the next application what they are saying means, the pulley system will be moving in the upward direction, as well as along with the motion of the pulley, the two blocks, one of the block of mass m1 will be moving in the downward direction and the another mass m2 will be moving in the upward direction with the same acceleration. So here we will assume that let A naught is acceleration of the pulley. Let A naught is what? Acceleration of the pulley, and which is moving in the vertically upward direction. So the corresponding equations of the acceleration of the system will be given by A is equal to m1 minus m2 into g plus A naught by m1 plus m2. So in the next concept, apparent weight, we will define why whenever the object will be moving in the upward direction, the resultant acceleration becomes to be g plus a. So keep in mind, whenever the system will be moving in the upward direction, the effective acceleration value is equal to what? G plus a naught. If the same pulley system will be moving in the downward direction, the effective acceleration value is equal to g minus a naught. So in the first case what we assumed here, the pulley system will be moving in the upward direction. As a result, the acceleration of the blocks will be given by m1 minus m2 by m1 plus m2 into g plus a. Similarly, the tension which is developed within the string will be given by T is equal to 2m1 m2 into g plus a naught by m1 plus m2. So in the place of g, what we are writing here? G plus a naught we are writing. Keep in mind, whenever the system will be moving in the upward direction, so either the lift case problem or apparent weight problems, there whenever the system will be moving in the upward direction, what we have to write? The acceleration of the resultant acceleration will be given by g plus a naught. Whenever the same system will be moving in the downward direction, the resultant acceleration value becomes to what? G minus a naught. Similarly, the thrust acting on the pulley will be given by 4 m1 m2 into g by m1 plus m2. In the place of g, again we have to write g plus a naught. So when it is, if the pulley will be moving in the upward direction, So in the second case, we assumed that we assumed that the pulley mass system will be moving in the downward direction. The pulley mass system will be moving in the downward direction with the same acceleration of a naught. With the same acceleration of a naught. In this case, already I told, whenever it is moving in the upward direction, resultant acceleration is equal to what? G plus a naught. Whenever it is moving in the downward direction, so resultant acceleration is equal to what? G minus a naught. G minus a naught. So here the acceleration of the system becomes to what? m1 minus m2 by m1 plus m2 into G minus a naught. G minus a naught. When it is, if the pulley block system will be moving in the downward direction with the constant acceleration of a naught. Again, the tension value which is developed within the string, is also to be given by T is equal to 2m1 m2 by m1 plus m2 into G minus a naught. Similarly, the thrust which is developed within the pulley, or the thrust which is acting on the pulley, will be given by F thrust is equal to 4m1 m2 by m1 plus m2 into G minus a naught. G minus a naught. So these are the three different applications. Whenever the pulley block system will be in the state of the rest, the general equations for the acceleration, tension and upthrust will be given by m1 minus m2 into G by m1 plus m2. Whenever the system will be moving in the upward direction with a constant acceleration of a naught, the corresponding equations are becomes like this. When the pulley block system will be moving in the downward direction, the resultant values of acceleration, tension and upthrust will be given by like this. So keep in mind, whenever either pulley block system or the lift case, so whenever the lift will be moving in the upward direction, resultant acceleration is equal to what? G plus a naught. If the lift is moving in the downward direction, again the resultant acceleration becomes to be what? G minus a naught. So this is what applications of the Atwood machine. Next application. So in this application, we consider three different blocks having the masses m1, m2, m3 respectively. So in this case, how many blocks we consider here? Three different blocks which is having the masses m1, m2, m3 respectively. Here, the block m2 will be placed over the surface of the table. The block m2 will be placed where? Over the surface of the table. So whenever the block m2 will be placed over the surface of the table, so its weight is balanced by the normal reaction. The weight of the block m2 will be balanced by whom? Normal reaction which is exerted by the surface of the table. And here m1, m2 will be suspended freely. M1, m2 will be suspended freely with the help of the string. And we assumed here the mass of the first block is greater than mass of the second block. Mass of the first block is greater than what? Mass of the second block. So that its weight will be acting in the vertically downward direction. Its weight will be given by m1g, and the weight of the third block will be given by m3g. It is m1g and it is m3g. According to the given condition, m1 is greater than m3. m1 is greater than m3. According to the given condition, if m1 is greater than m3, its weight m1g is greater than m3g. m1g is greater than m3g. So that out of these two weights, which one will be more? So m1g is greater than m3g. So that the m1g block will be moving in the downward direction. The m1g block will be moving in the downward direction, and m3g block or m3 block will be moving in the upward direction. Once again, here we assume what? The mass of the block 1 is greater than mass of the block m3. So here m2 will be placed over the surface of the table. Its weight is balanced by the normal reaction. So here what we have to understood, the motion of the system will be results from the weights of the M1 block as well as M3 blocks only. The weight of the M2 block does not causes the motion of the system. The cause for the motion of the system is what? The M1G comma M3G values. Already in the last class I told, whenever such type of connected bodies with the help of the strings they given, the first thing is we have to calculate acceleration of the system. The first thing what we have to calculate here, acceleration of the system we have to calculate. For calculating the acceleration of the system, what you have to require? You require what is the net force acting on the system. Net force acting on the system. If you look at the diagram, already I told M1 is greater than M3 means its weight will be more and its weight will be acting in the downward direction. So here the main cause for the motion is what? The weight of the first block. The cause of the motion is what? The weight of the first block. Since its weight will be more, so its weight will be bringing the block into the downward direction. So that here I will write net force is equal to M1G. So this M1G weight will be tries to bring the system into the motion in the downward direction. Whereas the weight of the third block, will be opposing the motion of the block M1. So here the block M1 is tries to bring the system and it is tries to moving in the downward direction since its weight will be more. But the weight of the block 3 will be opposing the motion of the block M1. So that here net force becomes to what? M1G minus M3G. So if you understood this simple logic, you will be calculate any one of the problem, any one of the application. Once again, so for taking the F net only the main thing here. So according to your material or according to any another books, they derived some equation and they simplified and finally they got the equation. So that is a time taking process. To find the F net, two things is required. Which weight will be causing the motion and which weight will be opposing the motion. Here M1G weight will be causing the motion and M3G weight will be opposing the motion. Why? Its weight will be more. Generally it is moving in the downward direction. Its weight is also in the downward direction, but it will be moving in the upward direction. So that it is moving opposite to the direction of the actual motion which is generated by the block M1. So that I took the net force acting on the system will be is equal to M1G minus M3G. Now I will write the acceleration of the system is equal to, already I told, net force acting on the system by total mass present within the system. So here what is the net force acting on the system? M1 minus M3 into G by what is the total mass present in the system? Total mass means we have to consider all the masses. Even though M2G does not causing any motion, we have to consider its motion while you are writing the M total. So that the total mass which was present within the system is equal to M1 plus M2 plus M3. So like this, we have to calculate the acceleration of a system in the case of the Newton laws of motion. So to understand this formula only is very important. If you understood that simple logic, the remaining are very easy. So this is a acceleration of the system and both the blocks are traveling with the same acceleration. Now we are going to calculate the tension values T1 comma T2 respectively. Now I want to calculate the tensions which are developed within the string 1 comma string 2 respectively. So I want to calculate the tension which is developed within the first string. For that I will consider the FBD of M1. So the FBD of M1. So here I consider the mass M1 and its weight m1g will be acting in the downward direction, tension T1 will be acting in the upward direction, and the acceleration of the system will be acting in the downward direction. So from this figure we draw the FBD of m1 mass. So here the actual motion of the block m1 will be acting in the downward direction. The motion of the m1 will be acting in the downward direction. So when the motion of the object will be in the downward direction, so if downward force will be greater than the upward force, then only the block will be moving in the downward direction. So that the net force acting on the block is equal to the downward force will be greater than the upward force. So that I will write F net is equal to m1g minus T1. So I want to calculate the value of T1 only. Again, here F net is equal to what? According to the Newton's second law, I will write mass into acceleration, that value is equal to m1g minus T1. So which mass you consider here? Mass m1. So that F net value is equal to m1 into A is equal to m1g minus T1. So I want to calculate the value of T1, so that I will write m1g minus m1 into A, m1g minus m1 into A. So what you got the acceleration value here? m1 minus m3 into g by m1 plus m2 plus m3. Simply you substitute the values of A value. m1g minus m1 into A value is equal to what? m1 minus m3 into g by m1 plus m2 plus m3. m1 into g minus m1 into A value is equal to what? Already we derive m1 minus m3 into g by m1 plus m2 plus m3. If you simplify this equation, you will get the result of T1. You will get the result of T1. So that if you simplify that equation, you will get the value of T1 is m1 into g into 2m3 plus m2 by m1 plus m2 plus m3. So like this we have to calculate the tension which is developed within the string T1. Now we are going to calculate the tension which is developed within the second string. Tension which is developed within the second string. We are going to calculate the tension T2 value. Tension T2 value. For that I consider the free body diagram of the mass m3. Free body diagram of what? Mass m3. So that when you consider the free body diagram of the mass m3, its weight will be acting in the vertically downward direction, and the tension developed within the string T2 will be acting in the upward direction, and the acceleration of the system is also acting in upward direction. So here the motion of the block m3 will be acting in the upward direction. So when the block will be moving in the upward direction, whenever the upward force will be greater than the downward force, so that the net force acting on the block m3 will be given by net force is equal to what? Upward force minus downward force. Upward force minus downward force. What is the upward force value? Tension T2 will be acting in the upward direction. Downward force is equal to its weight. So I want to calculate the T2 value. Again, according to the Newton's second law, F net is equal to mass into acceleration. What mass was present here? m3 mass was present here, and acceleration value is equal to A. Acceleration is equal to what? A. Again, the right side value is equal to what? T2 minus m3 into g. T2 minus m3 into g. So I want to calculate the T2 value. T2 is equal to, if this term will be came to here, m3 will be the common. So m3 into g plus A. m3 into g plus A. Already you got the value of A. What is the value of A? m1 minus m3 into g by m1 plus m2 plus m3. If you substitute the value of A, again if you simplify it, you will get the value of T2. You will get the value of T2. If you substitute the value of A as m1 minus m3 into g by m1 plus m2 plus m3 in this given equation, so the final result what you got for the tension is T2 is equal to m3 into g within the bracket 2m1 plus m2 by m1 plus m2 plus m3. So like this we have to calculate the acceleration of the system and the tensions which are developed within the given strings T1 comma T2 respectively. So to solve any one of the application, the first thing we have to calculate acceleration. How can we calculate the acceleration? By calculating the net force acting on the system. So like this we solved the given application. Next application. So in this given application, a wedge is given, or the inclined plane is given. So over the given wedge or the inclined plane, they place two different masses having the masses m1 comma m2 respectively, and these two masses are connected with the help of a light string. Already I told, when we take the light string, the tension value at each and every point will be remain same. So here also again we are calculating what? Acceleration value, tension which is developed within the given string. First we will resolve the weights. So here the m2g value will be acting in the downward direction. The weight of the block m2g will be acting in the downward direction. So already we discussed, whenever the object will be placed over the inclined plane, so its sign component value will be acting down the inclined plane. Its sign component of the weight will be acting down the inclined plane. So for that already we told, the weight will be resolved into two components. So one of the component is balanced by the normal reaction, another component will be acting down the inclined plane. So that from this given diagram, the m1g sin theta component of the block of mass m1 will be acting down the plane, and m2g weight will be acting vertically downward direction. Now here we are assuming that the mass m2 is greater than m1. So what is the assumption here? The mass of the second block will be greater than the mass of the first block. So whenever m2 is greater than the mass of the first block, so here if you observe the given diagram, m2g weight will be acting vertically in downward direction, and the weight component of the mass m1 will be acting down the inclined plane. So that by seeing that given diagram, simply we will tell the weight m2g is greater than m1g sin theta. The weight m2g value will be greater than the m1g sin theta. Why they mentioned that m2 value will be greater than m1? As a result, we will say m2g value will be greater than the m1g sin theta, so that the block will be moving in the downward direction. With a constant acceleration that only they represented in the given diagram. Now I want to calculate the acceleration of the system. Already I told, acceleration of the system is equal to net force by total mass. So here m2g is greater than m1g sin theta. So that F net value becomes to what? F net value is equal to m2g minus m1g into sin theta. What is the net force value here? m2g minus m1g into sin theta. So by what is the total mass present within the system? m1 plus m2. Total mass present within the system value is equal to what? m1 plus m2. So this point we have to understood. If m2 is greater than m1, if m2 will be greater than m1, their weights is also related by the same relation, so that m2g is greater than m1g sin theta. So this is the expression for the acceleration. Now we are going to calculate the value of the tension. See, to calculate the tension value, I consider the FBD of mass m2. So that the mass m2 will be represented like this, and its weight will be acting in the downward direction, and the tension value will be represented by vertically upward direction. So what is the acceleration? Acceleration value will be acting in the downward direction. So here m2 block will be moving in the downward direction, means downward force will be greater than the upward force. So here F net is equal to again we will write m2g minus t. F net value is equal to what? m2g minus t. So what is the F net? Net force acting on the block of mass m2. So according to the Newton's second law, I will write F net is equal to m2 into a. That value will be is equal to what? m2g minus t. So therefore t value is equal to m2 into g minus a we will get. T2 value is equal to what? Or t value is equal to what? m2 into g minus a. What is the a value here? Already you got the a value. What is that? m2 into z minus m1 into g into sin theta by m1 plus m2. If you substitute the value of a here and if you simplify the given equation, you will get the resultant value of the tension. Here, if you simplify by substituting the value of small a in this given equation, so the required equation for the tension is given by T is equal to m1 m2 into 1 plus sin theta into g by m1 plus m2. So this is a required expression for the tension for this given wedge-shaped application. See the next application. In the last application, they consider one inclined plane. Over that only one block will be placed and the another block will be suspended freely or the block. So here in this case one triangular shaped wedge will be considered, and for one side the angle of inclination value is equal to alpha. For the another side, the angle of inclination value is equal to beta. Which type of wedge will be considered here? A triangular shaped wedge will be considered. For one of the surface, for the one inclined surface, the angle of inclination is equal to alpha. For the another inclined plane, the angle of inclination is equal to what? Beta. So here, over the inclined surfaces, two different blocks are placed. Their masses are given by m1, m2 respectively. Already I told, whenever any one of the block will be placed over the inclined plane, down the plane, its sine component of weight will be acting. Down the plane, its sine component of the weight will be acting. So, for the block of mass m1 down the plane, its a component of the weight will be taken as m1g sin alpha. Why? For that inclined surface, the angle of inclination is equal to alpha, so that we write the component of the weight of m1, along the inclined plane will be given by m1g sin alpha. Similarly, down the plane, the component of weight of the second block will be given by m2g into sin beta respectively. m2g into what? Sin beta respectively. So that first we have to resolve the weight of the given blocks m1, m2 respectively. Now, first one what we are going to derive? Again we are going to derive the general equation for the acceleration. So here what we assume here, we are assuming that m2 is greater than m1. The mass of the block m2 will be greater than the m2 is greater than m1. We will write m2g into sin beta. m2g into sin beta is greater than m1g into sin alpha. If m2 will be greater than m1, clearly we will said m2g sin beta value will be greater than m1g sin alpha. So that here what is the net force here? m2g is greater than m2g sin beta will be greater than the m1g sin alpha means. So the net pulling force will be given by m2g sin beta minus m1g sin alpha. So the net downward pulling force will be given by F net is equal to m2g sin beta minus m1g sin alpha. Therefore, already we know the general equation for the acceleration. Acceleration is equal to F net by M total. Acceleration is equal to what? F net by M total. What is the F net value here? M2g sin beta minus M1g sin alpha. So that the acceleration value is equal to M2g sin beta minus M1g sin alpha by what is the total mass present here? M1 plus M2. So that the acceleration of the system whenever the two blocks will be placed over the triangular shaped wedge is given by A is equal to M2g sin beta minus M1g sin alpha by M1 plus M2. Now we are going to calculate the tension value. We are going to calculate what? Tension value. So I consider the free body diagram of M2. So that if you consider the free body diagram of M2, so the downward force value is equal to what? M2g sin beta, and the upward force is equal to tension T, and this is the acceleration. So the acceleration of the block will be down the inclined plane. So in the down the inclined plane, what is the force acting here? M2g sin beta. So that if the block will be moving in the down the plane, clearly we will say M2g sin beta value will be greater than the tension value. So that here we will write F net value is equal to downward force value will be greater. So that I will write M2g sin beta minus capital T. So again, according to the Newton's second law, if you apply the Newton's second law, what is the Newton's second law formula? F net is equal to mass into acceleration. Which mass you consider? M2 mass you consider. So that M2 into A is equal to M2g sin beta minus T. So I want the value of T. So that M2g sin beta minus M2 into A. M2 into A. What is the A value? We derive M2g sin beta minus M1g sin alpha by M1 plus M2. So if you substitute the A value in this equation and if you simplify, you got the result of T value. So T value is equal to, what is the T value you got finally? T is equal to M1 M2 into G sin alpha plus sin beta by M1 plus M2. So this is the required equation for the tension in this given application. See the next application. So in this application we consider a block of mass M. Which is placed along the horizontal smooth surface. This block of mass M is connected with the help of a light string which is passing over a smooth pulley. It's a very, very important application. So here over the given pulley we are applying some external force. So whenever we applied some external force, the system will be came into the motion. What is the system means here? In the system, two objects are there. One is the pulley, another one is the block. In this given application, the pulley should not be a fix. So that whenever you apply some external force, along with the block of mass M, the pulley is also came into the motion. Once again, when you apply some external force over the given pulley, along with the block of the mass M, the pulley is also came into the motion. So we will represent the tensions when you apply the external force of capital F. So here the string is in contact with the pulley at the two different points, so that the tension developed within the string is given by T, T. Already I told the tension is always acting away from the point of contact. And again, the one more point is connected with the block of mass M, so that this is the representation of the tensions which are developed within the given string. Now we are going to discuss the motion of the two blocks, the motion of the two things. One is about the block of mass M, and the other one is about a pulley. So here, if you observe this diagram, over the pulley towards the right side direction, external force F will be acting. Towards the right side direction, the force F will be acting, and Towards the left side direction, two tensions will be acting like this. Two tensions will be acting like this. So if you assume the pulley will be in the state of the rest, we will say the right side force is equal to sum of the left side force. So that I will write for a pulley, F is equal to what? 2T. For the pulley, F is equal to what? 2T. Next, we will see the FBD of the block of mass M. So over the block of mass M, the pulling force is nothing but tension only. The pulling force is nothing but tension only. So whenever some pulling force will be acting here, so the block will be came into the motion. The block will be came into the motion. So whenever the block will be came into the motion, I am assuming that its acceleration will be represented by A suffix B. A suffix B. So according to the Newton's second law, if you write F net is equal to mass into acceleration, so I will write F net is equal to what? Mass into acceleration of the block. So here what is the net force acting on the block? That is nothing but tension only. So therefore tension T is equal to M into AB. Let it be equation number 2. So from this I will write here, I will write the expression for the acceleration of the block. The acceleration of the block is equal to, acceleration of the block is equal to A suffix B is equal to, A suffix B is equal to what? T by M. A suffix B is equal to what? T by M, which is representing the acceleration of the block B. So here we have to remember a point. We have to remember a point when both block, pulley are in the motion. So what is the case we consider? Whenever the block as well as the pulley both are in the motion, one point we have to remember. I am assuming that if x is the distance covered by the, if x is the distance covered by the or distance travelled by the block, what we are assuming here, if x is the distance travelled by the given block, then the distance travelled by the pulley will be half of the distance travelled by the block. Once again, what we assume here, whenever the block as well as the pulley both are in the motion, so one condition will be there. What condition we have to remember means, if x is the distance travelled by the given block, then the distance travelled by the pulley will be given by, the distance travelled by the pulley will be given by half of the distance covered by the block, half of the distance covered by the block. So this is a point we have to remember when the block as well as the pulley will be in the motion, So if the distance covered by the pulley will be half of the distance covered by the block means, from this we will write, since the length of the string will be is equal to constant, so I will write acceleration of the pulley is equal to, half of the acceleration of the block. Very, very important relation. Acceleration of the pulley is equal to what? Half of the acceleration of the block. Why? The distance covered by the pulley is equal to half of the distance covered by the block. As a result, you will get acceleration of the pulley is equal to what? Half of the acceleration of the block. So here, acceleration of the pulley is equal to half into, what is the acceleration of the block you derive? T by M. So that T by M. So this is the expression for acceleration of the pulley. So I want to represent the acceleration of the pulley in terms of the force what we applied over the pulley. So here what you know, F is equal to 2T. So therefore T value is equal to what? F by 2. So here acceleration of the pulley is equal to, you got T by 2M. Acceleration of the pulley is equal to what? T by 2M. Here T value is equal to what? F by 2. Therefore acceleration of the pulley is equal to F by 4M. So this is the required expression for the acceleration of the pulley. Very important application. So this point we have to remember. What is that? If a block will be moving through a distance of x, the distance covered by the pulley is equal to half of the distance covered by the block, and acceleration of the pulley is equal to half of the acceleration of the block. Acceleration of the pulley is equal to what? Half of the acceleration of the block. That is apparent weight of a given body, in the moving elevator. So it's a very important application. So before going to discuss the elevator concept, first we will generally discuss what is the apparent weight, how can we calculate the apparent weight of a given body. So for that I consider a block of mass m is placed along the horizontal surface. A block of mass m is placed along the horizontal surface. Whenever the block is placed along the horizontal surface, its weight will be acting in the downward direction. Because of this block is in contact with the given surface, this surface will be exerting a contact force or a normal reaction over the given object. So always the normal reaction will be represented perpendicular to the surface of the contact. Here the weight is measured with respect to whom? The weight is measured with respect to the given contact surface, so that the weight of the measured body will be depends upon the state of the contact surface. If the surface will be in rest, so that its weight is nothing but a normal reaction. Okay, so whenever the surface will be in the motion, the normal reaction value will be changes. As a result, the apparent weight is also changes. So that whatever given body, the apparent weight of the given body is also to be saying as the apparent weight is equal to normal force exerted by the contact surface. So that the apparent weight is also to be saying as it is nothing but normal reaction or the normal force which is exerted by the given contact surface. For this application, the surface is in the state of the rest. So that the normal reaction value is equal to mg. So that for this simple application, we will say the apparent weight of the given block is equal to normal reaction, and that value will be is equal to what? Mg. So like this we have to calculate the normal reaction value in the case of the horizontal surface. Now we will coming to the concept of the moving elevator. So in that moving elevator, so we consider the first case. So either the moving elevator will be in the state of the rest or in the state of the uniform motion. So what we assume here, it is either in the state of the rest or it is in the state of the uniform motion. Already we told, whenever a system or object will be either it is in the state of the rest or it is in the state of the uniform motion, the acceleration of the system is equal to 0. Acceleration of the system is equal to what? 0. Now I consider an elevator. And I am assuming that the motion of the elevator will be in the vertically upward direction. So here the elevator will be moving with the uniform speed, so that the acceleration of the elevator is equal to what? 0. So in that elevator, I place a block of mass m which is in contact with the surface of the elevator. A block of mass m is placed where? Over the surface of the elevator will be placed, so that we have to calculate here the apparent weight of the block. If you draw the free body diagram of the block, so here the weight of the block will be acting in the downward direction. And the contact surface will be exerting a normal reaction. The normal reaction value will be acting in the upward direction. So here one basic point we have to remember. So already in the concept of inertia of the motion, I think the sir was discussed the theory. So if we are sitting in a bus, if the bus is also initially in the state of the rest, so that what is the state of our body? Our body is also what in the state of the rest with respect to the ground. If a bus is traveling with a speed of 50 km per hour, so with respect to the ground, the speed of the body is also what? 50 km per hour. So that from this what we have to understood, if a system will be moving with a constant velocity or a constant acceleration, if a system is moving with the constant velocity or the constant acceleration, whatever the objects are placed within that system, are also moving with the either same constant velocity or acceleration along with the system. So what we have to understood, if the elevator will be moving with the constant speed, the block is also moving with the constant speed. If the elevator will be moving with the constant speed, whatever the objects are placed within that elevator, those are also moving with the same constant speed or same constant acceleration. In the case 1, what we assume, the elevator will be in the state of the rest or in the state of the uniform motion at that time. Whatever the objects we consider, those are also either in the state of the rest or in the state of the uniform motion. So I am assuming that the elevator will be moving with a constant speed, so that the object is also traveling with the constant speed. So here, if the object will be traveling with the constant speed, the acceleration of the object is equal to what? 0. So that whenever the acceleration of the object is equal to 0, we will say the net force acting on the object is equal to 0. Net force acting on the object is equal to what? 0. Net force acting on the object is equal to what we will write here? Upward force is equal to downward force. Upward force is equal to what? Downward force. Why? The motion we assume it is in the upward direction, so that net force acting in the upward direction is equal to what? Net force acting in the downward direction. So what is the net force acting in the upward direction? Normal reaction. Net downward force is nothing but what? mg. Already here we told apparent weight value is equal to normal force. Apparent weight value is equal to what? Normal force. Therefore, in this case, the apparent weight is equal to weight of the given block. Apparent weight value is equal to what? Actual weight of the given block when the elevator will be in the state of the rest or in the state of the motion. So one point we have to remember, if the elevator will be moving with the constant speed, the block is also moving with the constant speed in the same direction. If it is traveling with the constant acceleration, the block is also traveling with the constant acceleration. That point we have to remember. Next, case 2. So in the case 1, we assume either the elevator will be in the state of the rest or it is in the state of the uniform motion. In the case 2, I am assuming that the elevator will be moving upwards with a constant acceleration. The elevator will be moving in which direction? Upward direction with a constant acceleration. If the elevator will be moving in the upward direction with a constant acceleration, the given block of mass m is also moving with the constant acceleration in the same upward direction. Once again, whenever the elevator will be moving in the upward direction with a constant acceleration, whatever the object will be placed within the elevator, that object is also traveling with the same constant acceleration value along the same direction. Again, now we are going to draw the FBD of the given mass. So the mass will be represented by m and its weight will be acting in the downward direction. The contact surface will be exerting the normal reaction that will be represented in the upward direction, and the motion of the block will be in the upward direction, so that its acceleration will be represented along the vertically upward direction. So here the motion of the elevator or the block will be in the upward direction, so that the net force acting on the block, can be written as net force is equal to, I will write, N minus mg. F net is equal to what? N minus mg. Why? The motion of the block will be in the upward direction, so that when the motion of the block will be in the upward direction, upward force is greater than the downward force. That only we wrote net force is equal to upward force minus downward force. According to the Newton's second law, F net is equal to mass into acceleration. So therefore, F net is equal to ma, that value is equal to N minus mg. Ma is equal to N minus mg. From this, I will calculate N is equal to ma plus mg. N is equal to what? Ma plus mg. So you take the m as a common value. So m into g plus a. What you got the normal reaction value? N is equal to what? M into g plus a. The same only I told at the first application of the outward motion. Whenever the outward motion will be moving in the upward direction, resultant acceleration value is equal to what? G plus a. So here what you got the normal reaction value whenever the lift will be moving in the upward direction, N is equal to what? M into g plus a. Therefore, in this case the apparent value becomes to be W apparent is equal to M into G plus A. So in this case, apparent value to be also to be written as, if you take G is a common, mg into 1 plus A by G. Mg into what? 1 plus A by G. From this clearly we will say, whenever the lift will be moving in the vertically upward direction with a constant acceleration, the apparent value will be greater than the actual weight. Because of this reason only, while we are traveling in the lift in the upward direction, we feel heavier. While the lift will be moving in the upward direction. Case 3. So in the case 3, we assuming that the same elevator will be moving in the downward direction with the same constant acceleration. Again, in this case also we are going to calculate the apparent weight. So whenever the elevator will be moving in the downward direction, the motion of the given block is also in which direction? In the downward direction only. Again, see the FBD of the given mass m, and its weight mg will be acting in the downward direction, and the normal reaction value always to be acting in the upward direction, and the acceleration of the system will be in the downward direction, so that the acceleration of the block is also in the downward direction. Now we will write F net acting on the given block. Here the motion will be in the downward direction means, so we will say weight of the block will be greater than the normal reaction. Since the block will be moving in which direction? Downward direction, so that the weight of the given block will be greater than the normal reaction. So that F net is equal to what? Mg minus N. F net is equal to what? Mg minus N. F net value is equal to what? Mg minus N. So again, according to the Newton's second law, we will write F net is equal to what? Mass into acceleration. F net is equal to what? Mass into acceleration, and this value is equal to mg minus n. Therefore, n is equal to, we will write mg minus ma. Therefore, the normal reaction value is equal to what? M into g minus a. N is equal to what? M into g minus a. This only again we discuss in the case of the outward motion. Whenever the pulley system will be moving in the downward direction, resultant acceleration value is equal to what? G minus a. Resultant acceleration value is equal to what? G minus a. So already we told apparent weight value is nothing but normal reaction. Therefore, in this case, apparent weight value is equal to, we will write m into g minus a. Apparent weight value is equal to what? M into g minus a. Again we will write by taking the g value as a common I will get apparent weight value is equal to what I got, mg into 1 minus a by g, mg into 1 minus a by g. If you look at the equation, the apparent weight value will be clearly less than the actual weight. Apparent weight value will be clearly less than the actual weight, so that whenever the lift will be moving in the downward direction, the apparent weight value will be less than the actual weight value. That's why while you are traveling in the lift in the downward direction, we feel lighter. Means that apparent weight value will be less than the actual weight. This is the application number 3. Next application is, suppose an elevator will be moving in the downward direction. By mistakenly, if the cable was cut, at that time the elevator will be falling vertically downwards with an acceleration A is equal to G. So when we said if the elevator will be falling freely in a vertically downward direction, the acceleration of the elevator value is equal to acceleration due to gravity. At this instant, what will happen now we will see. Already we know that whenever the elevator will be moving in the downward direction, you derive the apparent weight value is equal to what? M into G minus A. Whenever the elevator will be moving in the downward direction with constant acceleration value, you wrote the formula W apparent is equal to M into G minus A. So here we assuming that the elevator will be falling freely means acceleration value is equal to small g. If you substitute A is equal to G, apparent weight value is equal to 0. Apparent weight value is equal to 0 means what? Already I told. Normal reaction value also is equal to 0. Since apparent weight value is nothing but a normal reaction. Once again see here, whenever the elevator will be falling freely, the apparent weight value is equal to what? 0. Apparent weight value is equal to 0 means what? Normal reaction is equal to 0. What is the normal reaction? When the normal reaction will be existed, whenever the two different surfaces are kept in contact and they will be in physical contact between the two surfaces, whether it is a two surfaces or a block and a given surface, normal reaction will be existing. Here, normal reaction value is equal to 0 means what? The block will be leaving the contact of the given elevator surface. So whenever the normal reaction is equal to 0 means, whenever the normal reaction value will be is equal to 0 means, there is no contact between the block and the surface of the elevator. There is no contact between the block and surface of the elevator. At this instant, so weightless state will be existed. So whenever apparent weight value is equal to 0, which type of state will be existing? Weightless stage will be existing. That means the object will be floats in the air. The object will be what? Floats. There is no contact with the surface. Such state we are saying as either weightless stage or the object will be floating in the air. So then only we will say its apparent weight value is equal to 0. So this is the application of elevator concept. So your synopsis are completed. In the next class we are going to start the numericals. So before that, in the classwork exercise 1 to 30, theory bits are there. Application oriented problems those are. So you solve those applications and you write the entire explanation for that problems. Don't put A, B, C, D options like that. Question, and for that explanation you must write them that solutions to the given corresponding WhatsApp number. So in the next class we are going to start the remaining numericals. If any one of the numerical will be directly came with a direct formula substitution, I will left that problem, you solve them, and difficulty problems we are going to discuss in the next class. Thank you.